Manual ad hoc workspace creation with partitions requires physical effort and interrupts activities. We propose WaddleWalls, a room-scale interactive partitioning system using a swarm of robotic partitions to reconfigure workspace. Here is the system overview of WaddleWalls' individual partitions. Partition's height is adjustable between 1.3 meters and 1.8 meters. Our interface consists of a handheld controller and a visual monitor. Here, the user arranges the single partition near the user. The controller's position, height, rotation is recorded as a specifying target state. When the user pushes the specify button, the new target is recorded. Then the user dispatches the partition by pulling the trigger button on the controller. In addition, we design a quick height adjustment function using the upper and lower parts of trackpad button. The left and right parts of trackpad buttons are assigned to lateral position adjustment. In the visual monitor, we show the position of partitions, controller, and specified targets. The light and dark blue circles indicate each individual safety area when partitions rotate. An error sound alert is played when the controller's target candidate area overlaps other target safety areas, whereas an accepted sound alert indicates a successful assignment. We conduct a preliminary user study with 3 tasks to evaluate the effective partitioning experience. In the first task, the user experiences sequential workspace partitioning of 3 types of layouts. In the second task, the user experiences interactive height adjustment for face-to-face communication with colleagues. In the last task, the user experiences automatic partitioning for the online meetings using our preset function. In this scenario, the user can interactively create his private spot to protect personal privacy. An ad hoc private spot is configured by 4 partitions for his rest break. When the spot becomes unnecessary, the user returns all partitions to the home. In this scenario, when others enter the room and start group activities near his desk, the user easily protects his workspace from the surrounding visual noise. This scenario shows an example of a shielded desk user who decides to perform an ad hoc face-to-face chat by changing the height of partitions. Even when the shields are configured around the desk, the shielding effect can be controlled by the user. Next scenario is an example of creating a safer workspace in the room. Ad hoc physical shields allow users to create physical territories to avoid collisions between users. The last use case shows an example of providing temporary exhibition space. This layout can create a personal place for each user and also can be used as the display surface. Based on the study observations, we introduce 2 additional designs of the interface. First is a mobile visual monitor, where the users can see the partition's arrangement from each position. Second, we employ the partition specification method. The user specifies 2 endpoints to describe the boundaries of workspace. And the system automatically calculates the number of partitions that can cover the specified boundary and quickly lines up the target partitions.